Hey everyone, welcome to this event. My name is Shawa, and I will be facilitating tonight's session. And we're very glad to have Dmitry here tonight. He is just a quick introduction. He is a very seasoned and experienced data engineer, but he's worked in many different aspects, of big data, data science, and also engineering. He's currently data engineer working on game analytics at Microsoft. And yeah, he's been an analytics and data engineer leader with 10 years of experience working in business intelligence and data warehousing, data integration. But he also, works on big data cloud and has a lot of experience in machine learning space as well across North America and Europe. So we're very excited to have Dmitry here tonight to share his thoughts on analytics, modern analytics stack. So without further ado, I'll hand it over to you, Dmitry, and I'm
Yeah,
sure you do a much better job introducing yourself. And we really look forward to the talk. By the way, this is an interactive session. So if you have any questions along the way, feel free to send those questions to the Zoom chat. I will take some notes, so maybe we can take brief breaks in between, so we can answer some questions, or we'll have more time at the end to answer some of your questions, whether it's career related or any specific topics related to data engineering. Feel free to send your questions to Zoom chat. All right, let's get started. But thanks, Dimitri.
yeah. Thank you for introduction. Yeah, I'm Dmitry. I work with data, more than 10 years. So I think I'm lucky because I'm still in one space. So I did only one shift of industry, then like my background education. So I will cover this. Yeah, and since the time I work with data. So and now the data is very hot topic. So I just like to work with data stuff. So today I'm going to talk about different things because I found, okay, let's call it modern stack, modern data stack, and everything what you should know about this. So the idea just to show you some technology, what's currently happening on the market and the trends. And yeah, disclaimer that probably it's my personal opinion. So I don't know about the vendor. So in my current employer, Microsoft, because I will talk about Azure competitors, whatever. So personally, I like Tableau more. So I'm fan of Tableau, but I don't work now with Tableau anyway. So, but just like the product, whatever, just my opinions and thoughts about this. So the outline, yeah, I have, I don't know, around like 40 slides deck, and we'll go pretty fast about this because most of the topics is like, we could spend like the whole lesson just talk about like single slide. But yeah, it's a couple slides about myself. Then I look into backwards about what was happening major in industry. Also, we'll talk about roles in analytics space and data teams. And then we'll talk about my favorite topic about like different tools, technology, architectures, and share some of my projects that I've done in the cloud. So yeah, this is a slide about myself. So I even had written 7 books for now. Yeah, the most recent one is about Azure Data Factory, and before it was Snowflake book. So it was the first Snowflake book. I even got.
Dmitry, did you share your screen? Because we.
Oh,
Yeah.
do we need this?
Great.
Yes. I think I share. Let me let me stop share, and yeah, it was shared. Let me share it again and see how does it work. Do you
Looks
see
good.
it?
Yeah.
Okay. Okay. So yeah, that was the outline, and this is about myself. Yes, the books that I've written, And I still debating about, do I really need to spend so much time on this? Because honestly, it didn't help me in my career. So like, I think if you're gonna write book, 1-2 books is enough. Like you don't need to more. And also I like to, before COVID, it was fun to present on different user groups or conference. You could travel, just fun. With online experience, it's very different. Like you can see how many people sign up and few people show up and so on and so on. So, but we have what we have, and I decided, okay, slowly come back and just trying to contribute to different user groups and meetups. Yeah, I originally am from Moscow, Russia. I think the Moscow and Moscow region population is similar to Canada population. So I used to live in the big city. And then I moved to Montenegro, so very nice place. If you're looking place for retire, I think this is the best and the cheapest place in Europe. So similar climate to Italy, but very cheap. So then I moved to Winnipeg, spent 1 winter in Winnipeg, moved to Vancouver, actually Victoria. So right now I'm in Victoria, even not Victoria, so in the middle of the Vancouver Island. But I moved to Vancouver. So after 5 years in Victoria, most time of Victoria, I will move to Vancouver eventually. So I also spent lots of times in Seattle and Boston while I was working with Amazon. And before Microsoft, I spent 5 years in Amazon, and yeah, did a lot of user groups and talks. And also we have University of Victoria on the island, and I'm running their course for cloud computing. So just general cloud computing for non-technical professionals. Okay. This is my education. So it's me probably like 12 years ago. I used to work on the spaceship manufacture. So now it's very trendy to be close to the space. And before we just built the rockets. And my education is related to mechanical engineering. So this we build and calculate and draw different tools. Unfortunately, in Russia, no demand for this even now. So, and that's why I did the shift. So I've got internship in the bank and started working analytics. And since then I work in analytics and I enjoy this space. And one of my favorite benefit, because you don't really need any, for example, for anyone who looks to start, you don't need any professional certification. It's not like electrician, plumber, whatever. You need the skills. You even don't need like school education or university education. So you just need like motivation, go online, get the skills, you can get the job. For example, recently I helped my friend, he was the cook, he lost the job. And after 8 months of training, now he works as a Power BI developer. So everything is possible. Another thing I really like to do a picture of my workspaces. I think for the last year it's similar from my bedroom, but before it was very fun to travel and just experience different environments around. Okay, back to our topic. This is just starting talking about analytics. So let's define what is analytics. Very good to look in this from the business perspective. It's not about building pipelines or design data warehouse, whatever. It's actually to help business earn, like get more money or get value, find new products, mitigate risk. So if we look to the value, so they also call this value chain, value analytics chain for like any typical organization. So there are different groups of people like customers, employees, shareholders, and they look for different value. For example, owners of the company, they interested in revenue, customers interested in the quality of the products. So, and basically organizations, they exist to generate value. And the goal is to generate more value. So, and the only one way to do it better, so you need to make decision what is good for your customers, for your employees, for shareholders, for everyone, and what's bad. So that's why they need data. And my job is to help connect people who needs the data, who needs to make decisions, and with actual data. So I build pipelines, I consolidate the data and all that stuff to make it work and to just get some value for the business out of the data. Recently, I've got interesting idea about the door problem, because now I'm in the gaming industry. We just had a gaming Microsoft Research Gaming Summit. So there are like different scientists talk about how they contribute to the game design and so on. So, and they talk about the door problem. So the door problem, and this is the link for the blog post. So it's very nice. So assume you built the game and you want to add the door to the game. And this is examples, like if you couldn't just say, hey, can you add the door in the game? Because there are so many factors here. And like everyone, you can see a bunch of examples, like what every person, every role will ask about the door. So for myself, I'm as a data engineer or like the person who works with data, probably I will ask, how are we going to collect data? What kind of events the door generate? Do we want like streaming, or we can wait? Like, do we want to aggregate the data? So a bunch of questions. So, and the door problem is basically applicable for everything. The same with analytics. So if someone tell you, can you give me a report or dashboard, or can we collect this data? The same door problem. So sounds simple, but hard to make. Yeah, and probably there is some solution, but it just to be aware that it's not easy. It sounds very easy, but then you actually start to think about this and build. So it's very different. And in another picture I like, especially now, we have so many different technologies and approaches that often, like, assume the organization decide to build analytics, and they someone will offer them solution. They say, no, thank you, we are too busy. We're building our analytics. We modernize this or migrate. So, and they try to invent something instead of use the solution that already exists. And another problem on the market or analytics, so many data vendors, so many tools and technologies, and it's hard task. If you not spend like several years in this industry, I think it's impossible. It's impossible to just pick up the best solution, because of course there are different solutions. Each of them have the pros and cons, and there are some trade-offs. But so many technologies that, like, for example, fresh on the market, like the small startup that will pitch you that they solve all your problem, but reality is no, they won't solve all your problem. Or for example, in another case, they will tell you that this BI tool is free for use, but in actual, then you start to implement this and you already spent resources, you train your employees, and then you find, no, it's not free. It's free for some limited database connection. For your enterprise use, it's very expensive. So there are lots of pitfalls here. So just to be aware. Also, this slide I like, the key milestones. I tried to think about, okay, what do we have on the market and how the industry evolved? Because I was start work like around like 2010, and at that time we had like several positions, like either business intelligence developer, person who work with enterprise grade BI tools like business objects, MicroStrategy. Then there is the guys like ETL developers who built the data warehouse and they use Informatica, Oracle, SAP, like different enterprise grade ETL tools. And there are also guys like data mining specialists, because we didn't have data science, machine learning, AI, anything like this. I bet scientists had those terms about artificial intelligence and neural networks, deep learning problem. It was many years ago. But just in the industry, we had data mining specialists, and for example, one lady worked with me. She used IBM SPSS for doing some what we call now data science. Before it was just data mining, and I was thinking about what was happened before, and probably before there was just programmers. So the programmers, the coders who use different programming language, they can build and solve pretty any problem. And there was the challenge that it was very hard to actually build anything, because you need to spend a lot of time to code even the simple dashboard. You can think like, okay, we have some data somewhere, we want to build the chart. How are we going to do this? There is no any libraries, there is nothing. So people need to spend hours and maybe days and months to produce some meaningful dashboard. And then, for example, the Crystal Wrappers and some other tools, they release the tool that can solve your problem. You don't need to spend months and weeks to build the stuff. You can actually drag and drop, connect to your database, drag and drop and build report. So this is a huge win. The same with ETL, like with drag and drop, you can solve your problem. You don't need to code everything. And the IBM SPSS probably the same for some statistical problems. Again, drag and drop, and some, of course, you need to code a bit, doing some functions and using their own syntax, but it's still not the same as a build the product for yourself. And this is I just threshold for till 2010. Then people using like those different applications to build solutions, and then around 2011, the big data hype arose, and there was Hadoop. That probably everyone heard about Hadoop, and like there was some vendors around this, Hortonworks, Cloudera. I'm not sure what year they started, but they're related to Hadoop, and there was also like some microservices. So this is idea, just to give you how my thought process works, because there was we didn't have many different roles before, right? Basically, like several of them. Person who responds for analytics, and we didn't have many tools because there are like major vendors like Informatica, Oracle, SAP, and they provide the solutions for you for whatever work you want to do. And people, they're trained to use particular tool, and they also can, okay, if I'm a TL developer in Informatica, so for me, it's possible to just switch to SAP, probably the same idea. And then big data arise, and there are people who call them big data engineers. The main requirement was Java. And because I was in the basket with BI developers and ETL developers, for me, it was a bit shocking. Should I learn Java or not? Because all my friends starting to study Java and writing MapReduce jobs and do all those things. So for me, I still debate, do I need this or not? And fortunately, I don't need Java. Even today, I don't need Java. Probably I need Scala or Python, but I can even build the solution, not touch Python or Scala. So, and the idea here that in terms of the roles of the history, the next role was the big data engineer. And now we have BI engineer, we have data engineer, who is basically similar to big data engineer. And we also have data scientist or machine learning engineer. So, and I put like 2015 plus. So this is how, what currently they have, those people, those folks, and technology they work. So, and I will focus during my presentation on the last bucket, on the people, like those people, BI engineer, data engineer, so on, and technology and architecture that they're using. This is, I just put the Gartner hype cycle. So every year they publish what technology or what terms is just like starting to be popular, and see how they're going. And in 2011, they put big data there. So the big data just starting to rise. And then in 2013, we see big data was on top, on the peak. And what we have now, because for everyone, big data was associated with Hadoop technology and the Hadoop framework. And now many people debate, is Hadoop dead or not? So like all the problems that we see with Cloudera and Hortonworks, how they merge and they still struggling, and how, like I saw in other technology vendor that was rely on Hadoop before switch to, I think, Apache Spark. But maybe for some companies who use Hadoop as is with HDFS and lots of commodity clusters, chip clusters, and all those things, yeah, maybe they're not in the best shape. They can still use it, but right now with cloud computing, we can just avoid this. So overall, the approaches for distributed systems and the things that was used in Hadoop, we still use them. So if you go to the cloud, any cloud vendor, you can manage Hadoop for yourself. And it is good, it's working great. I use it a lot, but also now you have the choice to get the same performance and the same capabilities way simpler, way faster and cheaper, and completely avoid Hadoop. So just using the cloud computing and elasticity and other cloud benefits. So my personal opinion here, I couldn't say that Hadoop is dead itself, because the methods, how we work with big data, they're still alive. And yeah, probably I don't want to implement Hortonworks or Cloudera products for my projects, but overall, I admire what was done with Hadoop and everything good. So another major thing I want to highlight, the big data term. For me, big data means, first of all, is a technology. So it's the technology around Hadoop framework. It could be Apache Spark. This is for me big data. There's like Hadoop framework. This is big data, or some different like Hive, Presto, all those SQL engines. They big data for me. Or the data lake approach. This is big data for me. But I'm not talking about the data volume, or even about is it structured or not structured. I just focus big data for me, just the set of technology that is not data warehouse, that is not relational database. So some facts, because since we talked about different roles and especially like naming conventions in the industry and some keywords, so I put something that I remind me how it was maybe 5-10 years ago and how does it now. So first of all, everyone previously had business intelligence team, and we have like manager of BI or BI director and so on. Now it's probably manager of data and insight team or data team or analytics team and so on. And then we talk about BI solution. Oh, I hear my echo. Someone. Can we mute someone? Okay, so it's better. Thank you. So then, and we had like reports. Now it's dashboards. We talked about data warehouse. Now we can talk about data platform. And we had developers. Now we have engineers, and so on. So this is fun to see. But the problem here, and another interesting thing, yeah, we have the role data analyst that basically could be anything, everything. So if we see the data analyst role, it means, oh, it could be anyone, anyone, like, yes. And that's the big gap between job on the market and what actually company need. So it could be, they can put everything in the job requirements and they call it anything, but in reality, it could be completely different. So there's like, the gap exists, it's still there. And I think it's only growing because right now, with new approaches, new technology, it just continue exponentially grow what we can get on the market and what requirements could be. But the good news here, if we can get some foundational knowledge about how the things works, or like even the simple example of data warehouse and data lake and data pipelines, all that stuff. So it could be easy for us to digest any new information and any new technology related to analytics. So for me, I just see that the several current roles that exist related to the analytics is BI engineer, data scientist, and ML engineer. And often we can just union data scientist and ML engineer is one. And another one is analytics engineer. Even in some point of time, I renamed my LinkedIn profile to analytics engineer. instead of data engineer. And for me, it sounds cool. I was thinking, oh, it means I'm kind of like full stack engineer. I build everything end to end. The problem arises when I started to apply to the job. No one really know what does mean analytics engineer. They know what does mean data engineer, but they don't know what does mean analytics engineer. So that's why I put back data engineer. And yeah, it could be tricky with all those naming things. So it's probably the same as they put emoji in your LinkedIn profile. So some people understand, some people not. Okay, now we can talk about actual layers for the solution. Yes, if we talk about modern data stack, and for me, I always want to decouple these on the layers. So layers and analytics, it's very cool because you can split the whole thing on the layers, and you can control different layers, and you can assign different things to the layers. So there are 5 major layers. And the first one is very obvious. It's the source layer. It's the layer that basically generates the data. Starting from the most popular one, it's OLTP, online transactional databases. You can think about any online store, and then you buy something, record of the purchase, the order information goes into transactional database. And then there are lots of different services, API, social media stuff that you can consume the data, or it could be even more complicated. For example, IoT thing that sends you some data from sensors. Now we have lots of different gadgets and wearables and healthy gadgets, all of them streaming the data. And it requires different set of technologies. The next layer is data processing. And here we have 2 things. We have either batching, that is pretty straightforward and simple, or streaming, that is more expensive but serve to solve the special needs if they required. And then the storage layer. For the storage layer, we have data warehouse, big data solutions, and one of the most popular big data solution is data lake. And then we have science and experimentation layer. And I think now most of organizations invest into data scientists. So they do some kind of advanced analytics. And the last layer is a layer of their business users access to data. Usually we just call it business intelligence. So the thing is here that those layers, like, depends on the people, depends on the vendor, on their marketing brochure. Those layers could be anything, and the titles, they could have anything. So and my point here that for anyone, you just should make some kind of framework for yourself which will work for you to fit any technology. Because one of the key role of the person who builds solutions to choose the right solution for the problem. So understand the problem is the one thing, but also you need to choose the right solution. But the good news, if you choose the wrong solution, you still can build the solution. And it's especially with the cloud computing, you have enough like you can move so fast that even if you choose anything wrong, so you can still do this, and you probably could pay more using the more computing power and pay for this. Or for example, you can store a bunch of the data in the data warehouse and pay a lot for this, or you can store the same data in data lake, in the storage, and pay less. And those trade-off, but it doesn't matter that one approach is bad, another is good. They both equal. They just have different pros and cons. And also it depends on the skills you have. So I try to mark with the colors. So the data processing and storage is responsible for the data engineer. The science and experimentation is responsible for machine learning engineer or data scientist. And the business layer, where we have BI tools on the dashboards and self-service, it's responsible for BI engineer. Personally, I like engineer word more than developer. So, and this is cool. If you still call yourself BI developer or ETL developer, I think it's good to rename yourself to engineer. Why not? Okay. What's about data engineer at ML project? Because here we see, okay, data engineer is responsible mostly for the storage and bringing the data and consolidating this. And while scientists are responsible to work with the data, grabbing it out of the storage and do some different models, the actual data engineer contribute a lot to the work of data science and machine learning engineer. And I had several projects that I work on in Amazon with the data scientists, and I found that this is the best possible collaboration. Every person focus on their superpowers. So in my case, I can bring the data, I can automate, I can scale, I can provide the quality of the data, and the data scientist can work on the problem. He can take the sample, he can create the model, he can check it, and then everything good, I will help to scale the problem and automate the solution. And here I put in the green boxes like data collection, data processing, and data feature engineering. So this is all could be done by data engineer. And often organizations try to cut the cost in some extension, and they decide, okay, we have our BI engineers who is doing stuff. Let's get data scientists, or maybe let's convert our BI engineer into data scientist. So, and those experiments, they could fail. So this is very important point to hire the right people for the right role. Another topic I want to cover is data teams. And data teams are the teams who works with data. And there are two major approaches. One of them is centralized. Centralized means that you have a single analytics team or analytics department. And here you have two options. One of them, you have just, for example, you have single manager or director of analytics, and then you have a bunch of different BI, data scientists, data engineers. They work together. So, but if you have bigger organization, then you have one analytics manager who tied with the business, and then you have streams. One stream for data engineering, another for data science, and last one for BI, for example. And this is just depends on the team size and how you operate. For example, in Amazon, they always talk about 2 pizza size. So if you probably have more than like 30 people in your analytics team and they all report to you, so this is something wrong. So that's why small team can work faster. And another approach is decentralized. So it's just opposite. And you can think about if you will start implement people who work with data inside the product team or the marketing team, finance team, but you still need to think about the core team, because those people they can do think, but usually if we decide to do decentralized approach, it's good to have the core team who will set up everything, who will set up data infrastructure, and then every team can work and they can sync like once a week or bi-weekly. Let's move to another term. So now we want to talk about data processing layer. And there are two major things here. First of all, we have options for batch and streaming. The difference, it tells us itself. So the batch, we can allow it daily, hourly. Usually for data warehouse, it works like daily. Every night, ETL is running. And with ETL, we have two things, ETL and ELT. These two common things, but they're very, very different. And I would tell that personally for me, ETL, it's something for like pre-or 2015. So you can think about my chart with key milestones. So because all those things about cloud and data engineers started 2015, at least in my world. Everything what was before it was ETL. And the main idea here, where's your T happening, your transformations. With ETL world, you need the tool and you need very powerful host to host your ETL tool, for example, Informatica. So it's very expensive. The cost of Informatica could be the same cost as I don't know, the data warehouse vendor for you. And it should be powerful enough to consume all data and read through these. So basically it's process the data itself. And this is expensive. And of course you get lots of benefits in tools because they spend years to build different components for you to drag and drop that can do some work for you. For example, slowly change dimensions or generate surrogate keys. The opposite approach, even we use this back in the time using the Informatica, we use this into ELT using Informatica. So here what we have on the right side, what we want to do, we won't just take the data as is, put into our data warehouse, if we talk about data warehouse, and then do transformations with the SQL. And this is what's happening right now, because if you decide to, for example, you have Informatica, it's connecting to your Oracle database on premise, and then okay, I want to use all the same jobs that load my Oracle. I want that they start to load my Redshift data warehouse in the cloud. And then you realize your performance sucks. It's so slowly. It could be like, for example, 7 rows a second versus like 7,000 a second. So it depends. So the idea here that right now I just focus on ELT because we have really powerful analytical cloud data platforms, cloud data warehouse, whatever we have in the cloud. So it's very powerful, and we have storage there. So we just we'll put the data into platform, and then the platform, with the platform capabilities, we will process the data. So in another aspect here, then we talk about data processing layer. How would we work with our ETL? So, and here what we have GUI things, then we can drag and drop, and probably the Gartner quadrant on the left side, and you can see all major vendors, and even some fresh guys like Matillion and Fivetran. They also the only cloud, and they work with Redshift, Synapse, and what else? BigQuery, Snowflake. So those guys, they're fresh now, but there are lots of here, and for example, like Dinoda or Talent, like all them here, and they have GUI for you. Of course, you can use the code, but they have GUI capabilities. It means that you pay this company just because you don't want to write the code. And the opposite, for example, this is example from Apache Airflow. This is open source technology for very popular among data engineers and different companies. I think was initially built in Airbnb, so around like 2011, 2013, so whatever. And here we have the code. And this is one thing you should think. And because both of them have pros and cons. Another one, you can look again on the left, there are enterprise solution. You're going to pay for them, but in exchange you get commitment from vendor that it's going to work for you. And if some API connection will stop working, they're going to fix it for you, and they provide support. Or you can choose open source tools like Apache Airflow, Apache Nifi, Luigi, dbt tool. And again, I put them here because in my world, they're the most popular for the solution. And I also noticed that for different regions, there are different technology popular, because here in North America, we talk a lot about Redshift, Snowflake, and BigQuery, Azure Synapse. In Europe, people talk also about Vertica, Exasol, and some other vendors. And that's really depends on the sales office, like company founded, and how they like presents on the market. They both solve the same problem, and with all those technology, you can build a very nice solution. So this is example of Matillion ETL. It's the GUI app and SQL. This was built specifically for the cloud platforms like Redshift, Snowflake, BigQuery, and recently start support Azure Synapse. So it means if you build your cloud on build your solution in the cloud, and you don't want really code your pipelines and everything, and you have the team who comfortable to work with traditional tools or even BI developers, they can do this. So we can start use Matillion and do the thing. Very nice. Just drag and drop all components and complete the job. This is another tool, the Fivetran, and I put them together because they usually work together. dbt tool, they recently got funds, significant funds, and I think this is really cool technology. The community is awesome. In December, they had conference. They talk a lot about analytics, so it's very popular in different companies. So the benefit of dbt tool that it's basically T in your ELT process. So here you can define all transformations using the SQL, and then you can build a direct acrylic graph, DAG, and build the dependency and schedule. The downside of this tool that it doesn't load data. So you need to use something to load your data. For example, I just put the Fivetran. I know the Fivetran DB2, they have some join events, and they kind of like works great together. But also you can use any other tool, even just the scripting, just upload data in the cloud and then push into your cloud platform and then use SQL for transformation. So I like this tool, so brilliant. I mean, dbt tool. Okay, this is another example, AWS Glue, because all the cloud vendors, they have the tools for the data pipelines and data processing. So for example, AWS Glue, it's the tool that's available on AWS, works great for your ETL, and it's basically managed Spark. So you can use it Python or Scala to do your job. And it's opposite to Matillion that is so, because Matillion, for example, have a bunch of components. You have built-in component for Facebook, YouTube, Google AdWords. They can just specify your credentials. Here there is no component, so you need to write the code, probably use with Python, like request library to call API, to get token, authenticate, download the things. But it's all doable, just like pros and cons. And it's definitely cheaper because you don't need to buy the license, you don't need to pay hourly, you pay only when you use it. So if it's running, you pay. If it's not running, you not pay. This is example of Apache Airflow. So it's built on Python. Okay, now I can talk about next layer, that is data storage layer, and I will start from data warehouse. So everything what you should know about data warehouses, first, this is just database, and this is just the big database, and it's relational database, and it has tables. Tables has rows, columns, whatever, and you can use SQL to do all the stuff like joins, queries, and so on. And there are two types of architecture for databases. And one is SMP, symmetric multiprocessing. So this is, and I have really nice example with the washing machine. So the same, you have single washing machine, could be very powerful, but you can load it once, and it will wash your stuff. And the opposite, you have MPP, massive preprocessing. It also, they call it sharing nothing. So it's basically you have multiple physical machines that can distribute your data. And if you run the query, or like you need to do your laundry, you can run your washing machines all together. So they definitely will work faster than just you will wash everything in one machine. And it has many different benefits here. So my favorite product, it's a Teradata database. It was, I don't know, it's like since 80s probably. And I even used to work in Teradata, so I really admire their product. Now I couldn't say that they're in the good shape. They even have the cloud capabilities. Same with Oracle, they have cloud capabilities, but they just probably a bit outdated. And technology like Snowflake and other cloud things, they just started later. They used all cloud benefits, and they're working great. So that's my 2 cents here. But yeah, this is just Two keywords, SMP and MPP, that people who works with the data analytics data warehouse should know. Right now, all analytics data warehouse that we're gonna use in enterprise, they at least MPP. Next thing is the data modeling. So the data modeling, it's not the same as the data modeling for the data science, and we built our logistic regression model. So here the data modeling, we more talk about entity diagram, because we use data warehouse with relation database with relations. So we can have relationships between our tables. That is also called like the schema or the data model. And there are three major techniques on the market. First is dimensional modeling, that's proposed by Kimball, and there are lots of books. If you type I want book about data warehouse, you find a bunch of books from Kimball about data warehouse design, and this is classic. Also Royce Inman with third normal form, but they like similar. Data Vault, it's produced by Dan Lindstad. So I even one point of time I invited him to do the talk for my community at Amazon. He did the talk about Data Vault, but in Amazon, no one really used Data Vault. I even don't think that they really use data modeling techniques there. Just dump the data, bring the metrics fast. So that's the thing. And the anchor modeling, so this is another thing. So it's then you have like 6 normal form. So I don't have experience here, but I know that's also the quite popular things. I have the colleague who gonna do the talk on the Snowflake user group, probably in March. And he worked in San Francisco startup company, and he used anchor modeling with Snowflake. Works great. Okay, what is a data lake? For me, again, you probably notice I like to simplify everything till I can understand this. So one point of time I noticed that on iPhone, then I make the picture, my picture as a file, will upload to the iCloud, and then there is nice interface that I can type keywords and for example fire, and I can get the pictures of the fire. And then I realized this is actually data lake. This is a great example of data lake. So it's just the big storage that can keep all my data. In my examples, the pictures with files, but also it processes. While it's loaded the file, it processes it and it gets some metrics, metadata, and then I have nice interface for this. Even you can think of this is just business layer or BI, whatever you have, and you can search the information. So this is really good example of data lake. And then, because industry not probably it was valid, this type of data lake was valid for Apache Hadoop and big data stuff, then they actually start building a data lake, and everyone told that data warehouse is dead. So that's why now that everyone will tell you something is dead, it's probably not very dead, because the history knows those examples. Then we heard that this technology is not good anymore, and after some time they still continue to use. Who knows? Maybe we will start use cloud Hadoop in the future. The next thing is a lake house, or also call it cloud data platform. I grabbed this picture from Databricks documentations. So now I'm deep with Databricks. For me, it's just my personal challenge. If I'm so comfortable with all those data warehouse, data platforms, I want to be comfortable with Databricks just to understand the idea of the products. Because despite the fact what they're gonna tell you about the product, it's not the data warehouse and it's not the data lake. It's a kind of like mix of everything. But I'm really curious how it goes. And I will share the project that I'm working right now with Databricks in the end. So the lake house, the main idea here that with the cloud capabilities and everything, all stuff that you have in the cloud, especially with the idea that compute is expensive and the storage is cheap. So what we can do, we can keep our data in cloud, most of our data in the cloud storage, and then we can use compute machines to query our data. And now you have the mix. For example, let's look to the AWS. There is Redshift data warehouse, just data warehouse, MPP, classic. And then you can store some of your data in S3 buckets. So it's just in the storage, in the flat files, whatever you want. And you can start query your data from Redshift. So basically you create external table. The same story happens in Azure Synapse. Then you have your Azure Synapse Analytics, kind of like data warehouse, and some data in Azure Data Lake, and you can query from and you can create external tables. And the BigQuery similar, they all do the similar approaches. So that's why Lakehouse is just the thing that you have for the business users, it's just the SQL data warehouse. They open the SQL client, they type the queries, and there is the magic for them. But the data could be either in data warehouse storage and everything, or the data could be outside of data warehouse, live in the data lake. So that's why they call it Lakehouse. And this is example of AWS data analytics platform. Just the offering, like probably very old slide, but the idea that you have everything there. You for AWS, Azure, and Google BigQuery is everything you need for analytics. This is Azure Data Platform. So again, you have everything you need for work done there. And the Google platform. Again, different colors, different basic, but same idea. And like you even can see like the batch, the stream, real-time analytics, BigQuery table storage, and cloud storage. It's all what we just talked about. And since I understand like some concepts here, so I'm comfortable to read those architecture diagrams. This is Snowflake. The Snowflake is a really cool thing. And for me, it's first of all, because now the Snowflake probably grab the customers from all vendors on the industry, but they're doing this because what they did for me, they addressed all existing problems on the market, or most of them, like key problems for the person who work with data warehouse, like DBA or data engineer, and then they leverage the cloud capabilities and they ship the new product. And what they tell you for storage layer, it is SMP, and we just talk about SMP. Then you have like single laundry machine. For storage layer, it's SMP. For compute, it's MPP because you have multiple washing machine. And then you can scale up and scale down them. And first thing what they tell you, it is software as a service. They also call it data warehouse as a service. It means that you just start working with Snowflake, put data there, and you don't need to do anything. It will create backups, it will collect the statistics, it will make sure that data not skew, and you will get the best possible performance, and you will pay exactly right amount of money. So that's why this technology is definitely good. And I had some experience with Snowflake. I even published the book about Snowflake, and also I think one of the first in Canada I've got award for super data here for Snowflake. And this is something like just for the community award that I did some meetups and user groups and the books and presentation about Snowflake. So I like Snowflake. I like Snowflake, I like Tableau, I like DBT tool. So now I want to like Databricks. So we'll see how it goes. And this is the Databricks. The Databricks itself, it's the managed, because Databricks is just Apache Spark. So the guys who founded and invented Apache Spark, they create the commercial company Databricks. And for us, it's managed Spark. So it's the same if you go and launch your Spark cluster. But in this case, you just click one button, you get your cluster. If you need another cluster, you can launch another cluster. You can scale up and scale down this. And their approach for data analytics solution is Delta Lake. So and it supports Python, Scala, and even SQL. So Delta Lake, it's the same as a data lake, with the idea that in Delta Lake, you have Delta tables and transaction logs. All of these you need because the major challenge with traditional data lake, and I especially felt this in Amazon with GDPR and all those things, because it's very convenient to store like terabytes and petabytes of data in data lake, but then you get a requirement to delete customer data from your data lake. It's not the same if you go and query your database for customer ID, because in data lake you have files, and you couldn't simply delete the single customer record from your files of data lake. That's why it was major problem. The Delta Lake solved this problem, and you don't need Databricks for this. You even can use Elastic MapReduce and Apache Spark to build a Delta Lake, because it's Apache Spark offering the idea that you can work with your Delta Lake as a traditional data warehouse, because you can delete the data, you can find the customer ID, you can do update, you can delete, you can do insert. So all the same commands as you have with your traditional data warehouse. And then we talk about data warehouse. They think, okay, we want to load data into data warehouse. We put data into the staging, then we will have our data model, and then we have our data marts and connect to BI. So in Delta Lake approach, they have nice synonyms to those words. So they have 3 layers. Staging layer is the bronze layer for raw data. And then they have silver layer where they can process and clean data. And then there is the gold layer. This is your data mart that you're gonna connect to your BI tool. But here you can see a bunch of benefits, because since it's Spark and it has libraries for machine learning stuff, so your machine learning and data science team can work together in the same environment. This is one good thing. Another good thing I see, this is the streaming capabilities. And because you can basically organize your pipelines in the way that you can have the batch and you can have the streaming. You don't need another tool. Everything happening here. Yes, the downside here that you need to write the code for everything. And it has some things that I don't like right now. Maybe I don't used to. For example, how to organize the notebooks and how to organize the code and all those dependencies, but just it's cool to learn something new. And also I want to mention the company that recently came to the market in Canada. So I know some people from there. It's Dinoda. So they will talk about completely different story about data virtualization. So just to mention that some company using benefits data virtualization. Yes, in my personal approach, because I like to build stuff just with hands using those tools that I mentioned before. And if we will talk about the future for data analytics and what's happening on the market, so probably you may notice the data mesh approach, because all what I talk about, the data platforms, the processing layers, and so on, this is a kind of like monolithic architecture. It's all together. So, and here the idea is opposite, because like you can read the quotes, and I put the blog post about the data mesh. So it's kind of distributed, and it's very good work for huge enterprises, like really huge enterprise, where you can have multiple data warehouses or multiple data lakes, and they learn how to work together. So, and this is another big topic. And for me, I'm not there yet. I just want to be good with Delta Lake right now, but the data mesh is something that probably will come up later more often. Okay, let's talk about some of the projects. So the project, and I have some projects that I usually talk. There are not many of the projects, because every project took around like year, 2 years, so it's pretty big projects. Even I can put them in one small diagram, but they take a lot of time. The first project, it's Oracle Data Warehouse migration to AWS. So, and again, I use the layers, processing layer, storage layer, analytics layer, where I have the Tableau server. And then the next project's more complicated. And this is like just could be used even as a reference architecture for AWS, because it's using the batch, it's using the streaming, it's using the big data technology and the Spark and data lake and Redshift data warehouse. And all together, you know, the data lake and data warehouse together is a lake house. And there is some SageMaker and Athena. This is another service that can query your data lake and so on. So in other projects, interesting was my first experience collaboration with data science team. Then we did churn model for Amazon Alexa. And here, basically, I was responsible to bring in all data. I got requirements, bring all data, automate, and then use the SageMaker. SageMaker is the service on AWS that is really cool. So it's very powerful, and it gives us opportunity to use the notebooks, use pretty any language, pretty any framework, and this is kind of like managed service that you can spin up the virtual machines, and they will run model. So this is another project also from Amazon, the customer perception and feature attribution. So this also using the lots of data lake as a source, and then we process the data using Elastic MapReduce. This is Hadoop and Spark. So probably Hadoop is not yet dead because it's using a lot in AWS. So, and then we output, and there is another virtual machine that basically process this data and the deep learning model running there. And this is my current project. So then we consume lots of data from telemetry or other services, and it's land in Azure Data Lake, and Databricks processing things, and data factories orchestrate and manage dependencies. So there is the bronze layer, and then there is gold layer. Here's the bronze and silver, and then the gold layer, and we connect the Power BI. Also, machine learning models with help of MLflow can run here. Another major thing that I didn't mention before, and I even didn't really use in Amazon, it's DevOps thing. So because DevOps thing is very important on the projects, because you should split your dev and prod environment, and then probably you can work with the code and push the code to the dev, run the unit test, and push code to the prod. This is the reason why I have here DevOps pipelines and repo. So out of these, like everything what we have, so and nothing why I'll not forget, those things is not really possible when we work with GUI tool. So one of the benefits with the code environment, because it's pros and cons. One of the benefits of the code environment that you can easily use DevOps things, and then you can benefit from version control, change requests, and also deployment options. Because then you have GUI things that are like drag and drop things. If your team is scale and you have lots of projects, it becomes very hard to track what's happening because there is no transparency. It's just the files, the object that keeps the jobs, the dashboards, reports. So that's the downside of the GUI. So the key challenges overall out of all projects, one of them I want to highlight is a cross-team collaboration. And especially, personally, I'm data engineer, and you know my background. I used to build space rockets, not computer science. So that's why sometimes it's hard to work with software developer engineers who has like computer science background. And I just learned how to manage the situation to basically benefit from their experience doing design review and getting the best practice for software development and apply for data engineering. So another thing is BI team, this opposite. So because BI team likes to just create the custom SQL, put it inside Power BI, Tableau, and the work is done. But they can produce those custom SQL reports very fast. Every request will produce new custom SQL, new report. So eventually it will produce the house. So that's why it's another story. So with BI team, I try to keep all logics on major business transformations inside the data platform. And then BI tool should connect not to the custom SQL, but the actual data model or data mart. The data volume is still the problem, especially because it's not the problem to store even petabytes of data, but one of them, my project, for like 2 weeks, I should recalculate 1 year of data. That's approximately 700 terabytes. So that was the challenge, because in case you're running the pipelines and if something failed in between, so every iteration takes, I don't know, like several days to process this volume of data, and it's very costly. So then we work with the cloud environment. We accidentally can spend lots of money, so we can definitely set up alerts if something overspending, but also it's very good to budget your solution ahead, and then every month to just see how your budget is accurate, and are you staying the budget or not? If not, why? How to manage this? So it's just good habits. Security is also very good things, because in the cloud there is cloud shared responsibility model. That means that cloud environment and data centers very secure, but everything what you put in the cloud is your responsibility, responsibilities of the customers. So if you accidentally make the public access to all your data, is your responsibility. So the security best practices should be in place. GDPR and everything what's related to the privacy is the big problem, especially for international companies, because you don't know what to expect and what will happen in the future. So everything you build, you should think about that if someone will ask to get you the proof or delete the customer data, so you should have the mechanism to check and delete. Like if you need to delete customer data, so you can do this. If customer requests to provide the data upon request, then you should do this. So the last thing is the data quality. So data quality is very important, especially for machine learning data science projects, because it's very hard for us to actually, in BI, if something wrong, probably business leaders will find this and they will send you email that something wrong. That is not good, right? But it's still, they will find this. But with machine learning model, so since then you build algorithm and you push to the production, if you don't have any data quality, so and you send the wrong data, the model will give the wrong output. So that's why it's important. So my summary, there is no bad solution or vendor, because usually people can say, I like this solution, but I don't like another is crap. No, this is the wrong answer. They're all good. The company invested lots of money to build the products to delight the customers, so they're all good. And we can take any solution, even we can use spreadsheets, Excel spreadsheets, and build our BI and organize it in a very nice way and automate everything. So the solutions, they have pros and cons. And sometimes with the rise of new technologies like cloud computing, we can make the similar work faster, cheaper, and better. So, but it doesn't mean that Excel is bad or any other vendor is bad. So always we should focus on the business outcome, because especially with data engineering communities, we can talk a lot about different technologies, their pros and cons, and trying, and even myself, right? I'm talking a lot about how I'm gonna try Databricks, but someone gonna pay for Databricks computing cluster. So that's why we always should focus on the business outcome. Engineering excellence. This is my topic about conversation with systems team, so engineering team, and learn their best practices how apply to the analytics development, having all those version controls, repositories, and backups, everything, and security. So the job roles and description, this is also a good topic, especially when you try to hire the people. So be transparent and concise what you're offering, what exactly we're going to do, and what technology to use. We don't need to put everything like knowing Power BI, Tableau, MicroStrategy, SAP, C++, Java, and so on. Just be specific. And we can build solution using any code. Like, for example, many tools, like especially right now, I think number one code is a Python for data analytics, data engineering, but it doesn't mean that this is the best approach. There are lots of GUI tools that can give you the same result much faster. So I think I'm done with my presentation. If you have any questions, you're welcome. I just go and stop sharing.
Thanks, Dmitry, for the informative talk. It was really great. So we do get some questions on the in Zoom chat. So maybe we can go through these questions. So the first question is from Bayram. He was saying that Tableau is considered a visualization tool, but not an end-to-end business intelligence tool. Regarding this approach, he has an understanding that Tableau is very powerful with visualization, but it's not perfect for empowering business users in a company to answer their own question if they want to get out of the scope of the dashboard provided, and they can create their own dashboards. But this also means they need to build the data models and the relationships themselves, which can cause problem. And he wants to know, is this a correct understanding? And there are some discussions, below. So
I try to just briefly answer. So Tableau is a BI tool. So I think right now is one of the best tools on the market. So, but it's definitely, we should understand that Tableau is the like top of the iceberg. So it's responsibility of, I don't know, data engineering team or the other team, the data platform, data warehouse team, to build everything in place to, and then connect the Tableau. Because if we will give Tableau to the business users and say, hey, there is some databases, go and find the data you need. So that's, it doesn't matter what we're going to use, like any other tool will produce the same topic. The one thing that we should mention here, there are, for me, I split BI tools into two baskets. One of them is self-service BI tools like Tableau, Power BI, and another one is enterprise BI tools. Even Looker, the Cloud BI, or like SAP Business Object, MicroStrategy, they are enterprise BI, because before start building reports, you need to build semantic model. So this is your big data model inside BI tool. And then users can leverage this business model and drag and drop things. With Tableau, Power BI, and Qlik and other self-service BI tools, the users, it's like decentralization approach. The users can use the star schema, one table, couple tables, and start to building stuff their own. So it's again pros and cons. But if we look to the Tableau customers, there are companies like Cisco, Wells Fargo. They have 30,000 plus users. So it's definitely, we couldn't say that Tableau isn't BI or like it's not enterprise BI. So it's, I think it served the purpose. And yeah, it's the long conversation, and this was just my answer to this. It's not just the visualization thing. Visualization part of Tableau is just advantage and the benefit of Tableau that I personally enjoying, like the quality of the output of Tableau, but it has many other cool things for the data and BI.
thanks, Dmitry. The next question, I think it's related to one of the slides you talked about, which is data organizations. I think you mentioned different team models. So there was a question from Raymond regarding which team model is the most common in large organizations.
It's definitely, yeah, it depends. I think, for example, if we talk about Amazon, then there is decentralization, then you have small teams, because everything around two pizza team. Probably if we'll talk about some huge like telco company, or I don't know, some in North America, it's hard to think because they probably it's really correlate with the size. It's impossible for huge enterprise organization with, I don't know, 1,000, 10,000 people. It's just impossible to have centralized team. So they usually, it works in the way that there is the core team who built a kind of like central data storage or whatever they technology use, and then there is smaller team who connect to the central data storage and they can build, for example, Amazon again. So they have the central, the big data lake, and then small teams connect to the big data lake. There you have curated data sets. That curated means they good. Someone check them, and you can copy them into your data warehouse. Or like in my case with machine learning project, 700 terabytes doesn't fit Redshift data warehouse. So I take those data sets and put them in my own data lake. So that's the thing. And it really depends, but I bet it's more about decentralization with some central team who manage this core infrastructure for everyone else.
Great, thanks. So next question is related to a Slack channel from Jane. Yeah, so we don't have a Slack channel. So we have 14,000 members. How come we don't have one? So thanks for the suggestion. I think I'm gonna start a Slack channel, and we'll definitely invite everyone to join. So thanks for the suggestion. Another question. Well, our audience wants to know more about your background, Dmitry. Did you study a master of data analytics? Can you suggest which courses are the best for data analytics?
So yeah, I study for myself because, as I said, I studied mechanical engineering, so I know how to draw stuff like even 3D, whatever, or with hand I can draw like the gear and calculate the gear for the vehicle. But yeah, I never start even the databases or the SQL, so I just learn. And the good thing about the data that it's possible to learn just starting. You just need to kind of like good mentor, and the hardest thing right now, so much information about, and so much tools, course, everything. It's hard to find the right thing. But I don't have any education, and I wish to have education around AI. So for example, right now I know there are some executive MBA around artificial intelligence. So this is cool thing to have, but probably very costly. But study analytics, no, I don't have it.
Thank you. The next question is about, so Jeff is asking, is it possible for you to share the slides?
Yeah, I will give you the link to this presentation, and you can attach it to the meetup group.
Sure, sounds great, thank you. Next question, Nirab, can you elaborate more on what is data modeling?
So the data modeling in terms of data warehouse, because data warehouse is a relational database with the tables. So the data modeling will guide us what tables keeps what data, and especially depends on the technique that we're gonna use. For example, dimensional modelings, and it works in the way that we have fact table where we have all our facts on metrics or whatever. Like if we talk about e-commerce, so we will have information about orders number, revenue, cost, some other metrics with the bunch of IDs like product ID, order ID, or some like shipping ID and so on. So you can think about it's just the way how you organize your data inside data warehouse. And probably now it's applicable for data lake too, because since you can leverage the tables, like the Delta Lake tables in Delta Lake, so it's the same. So how you gonna organize your tables, because you couldn't save, technically you could save all your available data in one huge table, but it will be very hard to consume. That's why we decide, not me, but people decide to split all data and organize it in some logical way, and then physically split into the tables and divide them by areas. And then they have, depends on the techniques they're going to use. If it's dimensional modeling, they have fact tables, the heavy tables with all like sales records, for example, and then some dimensional tables. And then we start working with BI tools, for example, Tableau. We're going to connect our fact table and dimension tables and build our data source and build the report. But it's not easy topic. Probably in theory, it sounds easy, but when you actually get some business process and you get your data coming to design data model, it's hard. And there are, if you just Google like data, Kimball and Inman data warehouse toolkit, so they talk a lot about data modeling.
Thank you. So there's a question that was sent to me in private. As you work on game analytics at Microsoft, do you mind sharing, I guess, discussing the Minecraft game and Java popularity on it?
I don't work with Minecraft, so I don't know. I work with Gears of War, so I don't have any information about Minecraft.
Okay, cool. Next question from Smeet. How is the hiring process for data engineering at Microsoft or companies like, Amazon, and any tips, advice you would like to give?
So yeah, because I have experience with Amazon like 5 years, and I did myself lots of interviews for data engineers and BIs. In Amazon, it's very straightforward. If you Google how like interview looks in Amazon, you'll find the behavioral interview related to the leadership principles. There are 14 in Amazon, and they basically will ask you the question like, can you tell me the situation? Then you have the urgent project, but it was delayed, and what was your action? So they just looking to proof of some leadership principles in those questions. And then they will start going deeper. And then they have functional questions about, okay, can you talk about what is data model? For example, I ask, what is data model? Do you know what's dimensional modeling? And this is a very nice thing. Everyone, or not everyone, but most of the people who hire for Amazon for data engineers role will ask you about data model, but no one really uses them. And once then I changed the teams in Amazon from one to another, I got the question about data model related. So I forgot the answer. I just honestly told like, why you ask me this question? We never use it. So they accepted my answer. And yeah, this is like theoretical functional questions. And then they definitely will ask you the SQL, because Amazon is really SQL driven company. And finally, it really depends on the team, because if the team is building something related to big data versus Redshift, more traditional, so they're gonna ask you probably questions related to Elastic MapReduce, or will ask you Python, Java whiteboarding. So, but it's not happening often. For example, in Facebook, everyone will get the whiteboarding for the SQL, for the Python, even for the manager roles. So in Amazon, it's really depends. It depends on the team who hires, because usually if teams needs the Redshift experience, they will ask you about the SQL data warehouse. If we talk about Microsoft, then Microsoft has also behavioral questions, very similar to Amazon. And then they will also ask you to share the screen and do some coding exercises. So yeah, I don't know how good it's answer, but if you have enough experience, you just need to make sure that you understand what does mean behavioral interview. And then every answer for those type of the questions, you should give in the use the star method. It's star means situation, task, your action, and result. So that's basically it.
Thank you. Next question, what is the best way to find someone as a data analytics mentor?
It depends on your situation. So you probably, the best way is to go for different meetups and networking with the people while you not find someone who willing to do the mentorship for you. Because some people, they like to have to mentor the people, and they just enjoy this. Some people not. Some people they're busy, they don't have the time. But it's worth to ask, and you need to go. Yeah, the networking, I think, the best thing. And it's definitely, then we have offline events, and maybe one day we will get back the offline events. So it works definitely better, because it's probably strange if you ask the person, then you see the first time, can you be my mentor? But if you see the same person several times on the different meetups, that's probably worth to ask.
There's another question, private question. Are the skills needed to become a data scientist or work in AI harder to learn? I guess this is in comparison to data engineering.
I think, yes, I got this question. I think it's not harder, it's just different, because let's talk about data engineering. So the data engineering you can hack, and especially in Amazon world, you can hack it indeed, because you could be data engineer who is building data pipelines using the SQL. And I just call, there is like gentle data engineers, the people who is really similar to ETL developers that could use different applications, could use the SQL, or and they comfortable to use those like GUI tools, but they can accomplish the task. They can give the business result. They can help to data scientists. They can help the BI or the product manager. So everything nice. So the gentle data engineers, it's simple to start. It doesn't require a lot. The hardcore data engineers is basically similar to big data engineer. Then you need to work with the tools like Apache Spark or Hadoop framework, and then you need to write the code. So this could be slightly complicated, but with the Python, so everyone learns Python pretty fast. So you just need more practice. And if we talk about data science and machine learning, again, my opinion, for me, it looks more complicated because I need good knowledge of statistics. I need good knowledge of the math, algebra, all those things that I don't know right now. I forgot since my university, and I just not use this. So it's, if you use this every day, then you probably can do this. But for me, data engineering and data science, they're pretty equal on the knowledge. There is one special area for the data science, then for example, there is like research scientist or apply scientist. So this is not just the data scientists who know some Python and can build some models. Those people who has PhD degree in some area, and then they do research in this area. So those people, it's hard to become. Probably you need to get PhD, work in university on specific topic for several years, and then you probably can be this. For data scientists, it's similar as a data engineer, I think.
That's a great answer. Thank you. There's one more question. How does the recent trend in cloud adoption affect people who work in the big data world?
Yeah, this is coming to what is big data, right? As I said, for me, big data, it was the set of technologies, and the set of technologies around Hadoop infrastructure or like Spark infrastructure. So, and what I see, and again, like what we mean by people who work in big data. Some people who work in big data, who knows Java, who happy to write MapReduce jobs in Java and set up the Hadoop infrastructure and troubleshoot Hadoop clusters. They've got lots of money for doing their work. Definitely cloud will affect them because no one really need to set up Hadoop themselves, or writing the MapReduce in Java and troubleshooting all those stuff. Because in cloud, you can click a couple times and you get your cluster ready to running and executing your job. Even you can write the SQL to do the same job. So in this case, yes, it's affected. But in all other cases, when we talk about the benefits of the big data technology, it's became better. So it's became more unified. You can apply different languages, different tools to solve your problems. So I think the border between big data world and, for me, the opposite of big data world is the data warehouse world. So it's just diminishing, and we have like Lakehouse. So this is one of good example. Then we take best from two different worlds and we combine together. And the cloud, this is the platform where this change is happening, and they definitely for better.
Thank you. There's one more question. Do you know which organization offers volunteering or internship in data analytics?
It depends because I know, for example, all companies like Amazon, Microsoft, Google, and some other companies for students they offer internship, for example, after grade 3 or for the masters or for PhD students. There is career fair inside university. Even right now during pandemic, they're offering this. But if you just like, oh, I'm the person who wants to change the job title from what I'm doing right now to do internship in analytics, it's hard to find. I would say it's impossible. So my approach here, fake it till you make it. So just try to learn something to apply for the middle role. And probably you will fail like 40 different interviews, but after 40 interviews, you will get your first job. And this is how it works.
Cool, thanks. It's getting pretty late. It's 10 p.m. here in Eastern time. So I guess we'll wrap up. So here's the last question. How to pick up debugging skills related to data engineering issues?
Debugging, yeah, that's a good question. I think to get debugging skills, you actually need to start logging your work. So I would tell that it's more important to think about logging of the information, because debugging, for me, it's more about how I can find and prove that everything works as expected, and I found the quickly my problem. So this is more about logging. How can I log all my events? How I want to access my logging information? Can I visualize my logging information? So I definitely, I never use any debugging, but I care about how I will collect the metadata about my jobs running, about my pipelines, the data availability, everything, and how I can share this information with business users to make sure that they have the clear understanding what's happening with the data.
Okay, thank you so much for spending the time with us today. It was definitely a very informative, talk, and I learned a lot myself as well. So I hope all the participants have learned something new tonight. And yeah, thank you, Dmitry.
Yeah.
Thanks for your time, and we look forward to inviting you back. Maybe sometime in the near future. And yeah, thank you so much, and thanks everyone. We will. As a follow-up, we will share Dimitri's, the link to Dimitri's slides through a follow-up email tomorrow. We'll update that on our meetup group, and then yes, Slack. We'll create that, and we'll let everybody join.
Yeah.
So I hope we have a good evening, and back to you, Dmitry, if you have some final words you want to say.
No, all good. Thank you for inviting, and yeah, it's tough time for everyone now. I hope it will be better. We'll have our offline events, and yeah, just keep learning. And I already shared the presentation with you guys, so they will upload this and give everyone. So if you need more questions, just send me message LinkedIn. Yeah, have a good night.
Thank you. Have a good night, everyone. Thanks, Dmitry.